Okay, so if everybody can hear me on the web, yep, over there you can hear me talking over there. So everybody who's watching this can hear me now. So I'll just tell you about sort of what's happening. We've got two telescopes, one over here. That one's sort of trained at the moon at the moment. Just up there. That's about 82% full. And this telescope here is trained just off one of the stars of the Southern Cross. And on the screen at the moment, you can see just a cluster of stars, which is blotting in and out because of the cloud. Yeah, but that's actually the jewel box. And that's ordinarily that's quite colourful through just looking at the telescope, but through my camera it's all monochrome, of course. There's not enough light for me to put colour images of that on the web, but you can see it's a very distinct shape. That's the jewel box. Yeah. So
is that the Southern Cross there?
Is it
no, that's actually just off the star near the Southern Cross. Okay. So if you have a look at the star that's closest to the pointer, the nearest pointer, which is Alpha Beta Crux, which you can just see through the cloud at the moment. The jewel box is just a little bit off that star there. You can't quite see it naked eye, but through the telescope with magnification, you can see it quite clearly. Yeah, you can see it quite well through the screen. Yeah.
So that star you were just pointing at isn't.
Yes, that a bright star. I think. Yes, the one top. I think that is most likely Beta Crux. Yes, that bright star. So you can just see. Actually, I might be able to switch to a wider field of view here. Yeah, and it's a slightly wider field of view. So that's through that little. I'm running this through a little 50mm finder scope. Just there, with that camera there. And if I switch back to this field of view here, which is more magnified, I'm actually running that through an 80mm refractor, which is that one just there. So
you've got two set alongside each other. You can see.
Yeah. And this other telescope, it's can't really use that tonight. Well, I can get really close up craters of the moon, but tonight I think I can get some clear clouds up there. I might be able to get some Saturn through this telescope here. It's got a bit more power.
Yeah. You need better visibility.
Yes, I need a have less cloud about because it takes a bit of a while for me to find Saturn through that. So I don't think I'll attempt it unless it's really, really clear. So now it's Bill, isn't it? Yes. And you're from the Rotary in Delaware?
Yeah, Delaware Rotary Club.
Yeah, okay. So we've just got some visitors here in the backyard if you're listening in. We've got, Bill from the Delaware Rotary Club, and we've got Janet and Jim, who are members of our astronomy group here in Launceston. And we're just all gathered here. But hopefully if people can see what's happening on the net, you can see that there's lots of cloud coming in and out. So what we might do is switch back to the moon. Oh no, here we go.
It's amazing to see the stars through this.
Yeah, so that's actually what we're seeing at the moment. There's a bit of a delay between what's coming out of my camera and onto the yes.
So you're streaming this for the next 2
hours? Yes, so for as long as the clouds will allow me to stream, yes. And the NBN, of course. Yeah, so what's basically made this... Yeah, so... I don't understand where this is looking.
I mean, it looks like it's looking out there, but it's got to be looking back here. It's looking to the moon.
Oh,
No,
that one's looking at the moon over here. Yes,
That
I've
one.
got three
So
telescopes.
it's-
Right, yes,
That makes more sense.
yes.
That's all right. I understand that now.
I'm thinking, how the hell do you get the moon from that? And of course, both the telescopes are mounted on mechanised mounts.
Right.
Okay, and they're tracking the moon, not specifically, but hopefully they're keeping up with the moon, which this one pretty much is. We'll just flip back.
So it'll keep, if you focus it on the moon, it'll keep moving with the
more or less. Yeah, more or less. Sometimes there are sort of small inaccuracies, and sometimes if I have to just move back to the moon here, wait for it to. Yeah. So there's a bit of cloud about at the moment, so just bear with us if you can't see anything on the screen. We haven't done too bad tonight. Okay. Oh, you can see the jewel box just coming back into view there. And up here's the moon.
Yeah, sure, a glimpse there.
Yes, so just reduce that field. So I've got to go back to my screen actually. Jeez. Hopefully it'll come back there in a minute. Yes, lots of little clear spots that you're teasing us tonight. Yes, but just there in the moment. So thankfully the moon is bright enough to pierce through the clouds that looking for it.
Yeah, you'll see it first on the screen. You'll see it on the side. Good. Scopes are so powerful.
Here we go. There's the moon.
There
There we go.
Oh,
Just go back to just there we go. So I've got a nice clear shot there. You can see that.
Amazing.
So the screen will catch up in just a second for those on the net. I'll just wait until that does.
Yeah.
There it goes. Now the big bright crater that you'll see just near the top of the screen, that's got a. You can see all the lobes centre. What's happening? What's made that crateroid or comet or whatever has hit there, and all the ejecta has spread out across the moon and left all these lines of spray of debris. And so it's one of the objects that you can see quite clearly through binoculars if you've got them.
so how long ago did that happen?
That's in geological terms, that's relatively recent. But probably in the millions of years, sort of thing, which in geological terms is quite recent, of course, when you divide that into the billions of years. Yes. So now just
Another bright one. About a third of the way up on the left-hand side there. You still see through the cloud.
yes, this one.
Yeah.
Right there.
No. So go left. That's it.
Yes, that is Copernicus. Yes, and they've got a few bright, really sharp craters near the edge there. Now that's because the sun. That's where the sunset or the sunrise is on the moon, and the sun is at its sort of at its angle, maximum angle there. So it's actually picking up the shadows on the edge of the crater and causing them. And so that's why you've got quite sharp detail on the limb of the moon there, but not so much
But that's going to vary
as you go back. But there's still quite a bit of detail. The darker areas that you see, just around these areas here, they're what we call lunar seas or mare, and they're caused by areas of intense volcanic activity, which would have happened earlier on in the moon's sort of early years, sort of 2 billion, 3 billion years ago, that sort of thing. So yeah, no, it's not actually water, but it's there was a form of liquid there originally, in the form of lava, and that's sort of come up and sort of flooded that plain, making it flat, and sort of relatively recent, of course, because it's sort of it's covered over, and there's not as many impact craters in those areas as there are in the older areas where there's lots of impact craters. So a lot of people who study the moon gauge the relative ages by the number of craters that they see.
So the moon is not bombarded anymore.
Yes, yeah, it's not within. It's not bombarded as in the early stages of the solar system, when there was a lot of what they call the early heavy bombardment, when there was a lot of movement of the big planets, which was causing a lot of stuff to be thrown at the Earth and the Moon and Mercury and Mars. But these days, yes, it's plausible. We see asteroids fly past us all the time, and it's only a matter of time before one will hit the moon, or it could be this year, next year, 1,000 years, 1,000,000 years, or one hits the Earth, of course.
But they do track it. It's heading towards the Earth.
Yes, mate, they can track them. They can find them, but it's not 100% definite that they'll find. They find them all, of course, but
so we could get a surprise.
Yeah, we could. Yeah, it's well within on the cards. We could get a surprise.
Well, that's it's in the centre of
but certainly the larger objects, people like NASA and the United States Naval Observatory and a few bodies like that spend a lot of their observing time looking for these objects with a view of being prepared for a strike if that looks like it's actually going to happen. And of course, you don't want to strike like Copernicus, Tycho there, because that would sort of definitely destroy a continent. The size of that is sort of at least sort of in the hundreds of kilometres across, as we're looking at it there.
So that could move the orbit.
Sorry,
so that could move the orbit of the.
Yes, yeah, they could. They can cause the moon to vibrate. First, could it move its orbit? Maybe infinitesimally. Yeah, possibly. Yeah. There was reports by monks in the 11th century of an explosion on the moon, and people believe that was a reliable account. Even though they saw it during the day, they actually saw light coming off the moon, and it was recorded by the abbot of the monastery, and they believe that they might have found that crater, and they think they can even tell from the movement of the moon and the surface that the moon's actually still ringing, sort of as a result, sort of thing, vibrating. So that's you'll see a nice crisp view coming up, very clear at the moment. Just wait for those clouds to clear.
So you said there's volcanic activity. You have to excuse me. I've never studied it before. So it's molten in the centre, the same as.
No. As far as we know, no, the moon's no longer molten in the centre. No, it's lost all its internal heat in that sense, not like the Earth. So no longer can the moon sort of have that sort of wide scale volcanic activity, which you can sort of see the result of it, obviously, in those lunar mare.
So what happens that it ceases to exist, that it's a molten centre? I mean,
it's just a solid centre now.
Yeah. Well,
it's just
we have far less volcanic activity in Earth than we used to. So.
Yes and no. I think the Earth goes through different phases of volcanic activity, and that's constantly fueled by the movement of the tectonic plates in the continental drift, as continents are slowly sort of absorbed and plates are sort of are gathered underneath, and other plates move forward over the top of those, and that's what causes the ring of fire around the Pacific specifically. So that generates a lot of volcanic activity. There are also weak spots further on plates, like the volcanoes in Hawaii are what they call shield volcanoes, and it's actually a weak spot in the crust. It's not so much an edge of the tectonic plate. So as long as the continents keep moving, there will always be volcanic activity on the Earth. And depending on what's happening any time in geological history, that can be more or it can be less, sort of thing. But ultimately, yes, it's fueled by the mantle of the Earth and underneath in the core. And as long as that stays hot and active, I guess you'll have all that movement, especially over the top of the mantle, which the crust basically floats across.
The most fascinating thing,
yeah.
I guess is the latitudes that exist out there in the centre of
no, I haven't been to those. Yeah, so you can tell me more about those.
Well, they're like you walk through like a giant tube, which is supposed to be a lava flow, and because it cools slower in the centre flows out, and it leaves this giant tube.
Yes, I've seen people walk through those on TV shows.
It goes for kilometres.
Yes, yeah.
And you can see it from this very flat country. As soon as you get up a little bit, you can see that where these lava tubes are, because it's green from vegetation. We've actually created vegetation. But to walk through a cave that is created by the flow, the lava flow of the volcano.
Yeah.
How and we're talking about meters of lava. We're not talking about little tubes you've got to duck down. We're talking about cavernous things that are 20 foot in diameter.
Oh yes. So you've got a lot of power of molten rocks, sort of, and those structures can propel and generate. Yes.
When you delve into lots of things that exist in this nation of ours, we've got fossils in the middle of Australia. We've got what do you call it? Glacier flows.
Yes, in the glacial valleys. Yeah.
In the Flinders Ranges. They're sort of proof that was the end of the ocean.
That's right, and there was at one stage a huge inland sea.
It's a nice view, man.
Right, yes. So we've got some nice views around the Southern Cross. So we might flip back to the gel box just for something different. So just bear with us for a moment.
They're happy just to sit there and look. They don't want to have a look at the
It's amazing. When it's gone, you can see the scope, and then you can just see this view you can make down. You have to look at that.
The best thing for is to get being suddenly strong on your parents and just lie there and wait till your eyes just apply the dark the amount of stars that you can see. It's unbelievable.
I've got a bit of elevation as well. Where is it that in that place in Western Australia?
Don't know.
So just bear with us. There'll be some. We'll have the jewel box back in a moment, and once we get that on the screen, I'll move the telescope to another object, just to make things a little bit interesting.
So there are people following this event tonight, and they can hear what you're talking about, but they can't speak back to you.
Yes. At the moment, if they're following it on YouTube, they can hear me. They can't sort of speak back to me. If people want to dial direct into the Google Hangout, there has the capacity for that. But tonight, just to keep it simple, because I'm dealing with technology, I don't think I want to really complicate things that much. There we go. Well, there we go. If people can see the jewel box there again, now I'll just give you some information about that. Okay, so the jewel box is a cluster just near the Southern Cross. It's the second brightest star, the Southern Cross, called Alpha Crux. And it's an open cluster. It's circumpolar in the fact that technically it never actually sets below the horizon. When the sun rises in the east in the morning, it's still there in the sky above the horizon, but you just can't see it with the telescope, along with all the bright stars, of course. Approximate distance, I'm just looking up now. We've got this almost 6,500 light years away. We're looking. So
Similar to the Southern Cross itself.
no, that's the star that's near. It's near is actually a lot closer. Yeah, probably within the hundreds of light years. So what we've got now is the Southern Cross. Is the jewel box there 6,500 light years away. So when we talk about light years, we're talking about light that left that object 6,500 years ago, and it's just hitting the Earth. So quite within, maybe if there was a huge red star in there that was near at the point of its life where it would go supernova, and it did that today or yesterday, we wouldn't know until another 6,500 years. So yeah, so we well and truly will have moved on, perhaps even forgotten some of this stuff and have to rediscover it.
Thank you. It's good honey. How did you know? There are spies in the group, are there? Thank you.
Okay.
But it's still relevant, isn't it? It doesn't matter whether
Yeah, from our point of view,
it's
when
now.
a star blows up, it's now. It's happening
now.
now. Yes,
Yeah.
that's right. Yeah. But it is a good thing that when we look out, we're looking back in time, and the further we look out, further back in time we look, and so that's how we can discover about the history of the universe is by studying the sky. Yeah.
No, he's talking to you.
Yeah. So what I'm going to do now is I'm going to attempt to find another object So what I'll do is I'll flip it back, your picture you see, back to the moon, and what will happen on my other telescope, I'm going to try and move that to just got to go. Yeah, so I've just lost the live link. So just refresh the screen. Okay, that's good. We're live again. Right, so I've just got to adjust the telescope until we find that particular object that we're after. So I'm just going to put it on the screen while I send it the object, just to give you an idea that the telescope is it's all live and it's all happening right now. Okay. So I'm just going to center that object, and this is a huge globular cluster. It's called Omega Centauri. Now, just the screen's just oversaturating there at the moment, just while it works out how it's going to deal with all the light that's coming in. Okay, so it's a monster. Current research seems to suggest that Omega Centauri is a small elliptical galaxy in its own right that's been absorbed into the Milky Way at some time in the past. The center of that is quite saturated with my view of with this particular camera that I'm using. But through the telescope, it's a lot more delicate if you're looking with the naked eye through the telescope, and you can see a lot more resolution of individual stars. But certainly, what I'm showing you now gives you the overall impression.
Are they all at different depths?
No, they're all clustered together, pretty much. Yeah, well, they all would be at different depths within the cluster, which would be light years across, obviously. But from effectively, from our point of view, they're more or less the same distance in terms of light years. which I'm just about to find that information out about you for you. Sorry, it's all on the fly here tonight. Okay. So yes, we've got an object light years away.
17,000.
Now,
6.5.
this is a monstrous object. And what bears testimony to that is the fact that if you go to the pointer that's nearest to the Southern Cross, and at the moment, I'll use the direction as at the moment. If you move to the west, you see a lesser bright star, and if you move the same distance again at the same about at the same direction, you can actually see a Mega Centauri with the naked eye. And this is an object that's 17,000 light years away, so it's actually bright enough to see the naked eye. I can see it because I'm used to sort of staring that spot and recognising it. It's probably a bit hard maybe for people with me here to convince them that they can see it, but it's definitely there if you go out and take a star chart with you in the night sky, find the Southern Cross, and then look up a Mega Centauri, and you can see it usually as a bit of a smudge in the sky. It's not a very bright smudge, but it's a smudge that's 17,000 light years away, and approximately, I'm not sure how big it is in terms of light years across. Diameter, yeah, 271 light years across. So across the object, yeah, that object. So you're looking at an object that's that from the point of view of light reaching one end of it to the other, it would take 271 years for light to travel from one end of that cluster to the other.
Yeah, that's getting hard.
Yeah, that's right. But of course, in approximate terms, all that light we see now is light that left there 17,000 years ago, of course.
So you said that this is not an open cluster, this is... it's not an open cluster, this one?
Yeah, it's a globular cluster. Well, from the point of view that it's a big glob. It's all concentrated together, and you're talking about millions of stars concentrated together. Now, the reason they're pretty confident to call this an elliptical galaxy, a former elliptical galaxy in its own right, because obviously it's part of the Milky Way now, is that it has its own black hole in the centre. The Milky Way has a black hole called Sagittarius A, which is in the constellation, from our point of view, it's in the centre of the galaxy in the constellation of Sagittarius, the Archer. But that object has its own mini black hole in the centre, well, mini in terms of, it's not micro, but it's, it might be about 30 miles across in terms of its event horizon. Don't quote me on that. I'm just throwing that out there just to give you an idea. The black hole in the centre of the galaxy is something like 4 billion times the mass of our sun. So it's it's a huge object, and the object in the centre of this galaxy would probably it might be in terms of 100 times, certainly a large object. So if anybody wants to correct me in the comments on YouTube with that information, I'm quite glad to be corrected. So, but certainly it doesn't detract from the visual effect of it, of course. Yes. Yeah. So there's another globular cluster in the southern sky called 47 Tucane. So what we might do, just for the point of view of comparison, we'll attempt to find that one. Okay. So,
you've been pretty lucky with the sky.
Well, now there's something going. There's probably a satellite, or maybe even some kind of asteroid, or who knows? I'll have to look that up. Wasn't expecting that. So. Something maybe it could have been a satellite or something that moved across the screen.
As well as streaming, is this going to be recorded?
Yes, it'll all be on my YouTube channel. So yeah, so people can go back and have a look at it. Yes, it's all recorded for posterity. Now, if you just give me a moment here. We're about to operate to the telescope again. So again, anything could happen.
Yeah. Yeah. So that's a big one.
The battery's gone flat, so I've just got to replace the battery.
How long did it last for?
Oh, well, this has lasted for a few hours. So this is live astronomy.
And all the scientists like Darwin and all the others don't have one science. They've got theories, but that's all they are. Theories. Mostly, it never becomes fact, does it? The Big Bang is a theory that I don't understand. With massive,
Wow. Just keep talking about
they're really massive actions.
wasn't it?
It's very cool. Yeah, my legs got 2 legs.
So hello there, everybody. This is me. If you can see me in the dark here? Shine the light on me. Looks pretty ghostly. Okay, but I'm just going to share the screen here again. Moon on.
I've got a screen over. Then your video is really spectacular, much more than this.
Well, one interesting is that
That's what for Michael's got some video.
Here we go. Or it should show up in a second or so. Okay. I'll put just a full limb shot there, so you can just see the moon. That's the total field of view of the camera, and what you've been seeing previous to that is where I've used that black square on that white square on the screen to zoom up. So here we go again. I'm going to move my other telescope. So again here, no promises. Anything could happen. Catastrophes, as people that who might have used these telescopes will tell you. They can do some strange things at the best of time.
Probably not worth it, but they're only $40 or something.
What is it? $40, you get $40 there.
That's exactly
get there one or two lucky.
They call them the painters. Is that because they call it points out?
Not in this, not in the southern hemisphere. Pretty silly, pretty silly. And Orion's upside down, that really bothers me.
That's what I want to say. I got where you are.
It took us a while to work out what the second cross was. What was he on his guide? Oh yeah, that must be, there you go, that's just sad.
So just excuse us here, we're just battling with a bit of cloud. As you can see, the moon's just winked out there a bit. Yeah. Right, so the cloud's been very mean to me. I can't find this object, unfortunately, because it's the cloud's persisting in that area of the sky. Okay, so what we might do, we might try and find something else instead. So if you just bear with me. Yeah, some of those star charts are, yeah. Just a bit blind with my glasses. There we go, that's better. So what I'm getting the telescope to do now is to slew to the closest star to our solar system, which is Alpha Centauri. So if you just bear with me again, I'm saying that a lot tonight, but this is just the nature of the beast, unfortunately. There we go. Yeah, so you'll see all the streaking across the screen. That's because the telescope is moving. So so you can see by the basically that oversaturation in the middle is the star, or it's actually two stars, and there is a third one a little bit further out. But through a reasonable telescope, you can actually split that, and you can actually see the two stars. The nature of the video camera just presents it as a saturated blob on the screen, of course. So what's happening there? That star is 4 light years away. So it's next door in galactic terms. And just sort of right next to us in universal terms. So you've got two stars there which orbit each other. I think it's something like 80 astronomical units or something of that nature. An astronomical unit is the distance between the Earth and the Sun, so which is about 150 million kilometres. So if you multiply that by 80, then that's the distance that those two stars orbit each other, and so that light is 4 years old. If one of those stars was the kind of star that was about to blow up, we'd know about it in 4 years after it happened. There is a smaller star further out, and which is what we call a red dwarf star, which is quite faint. So we generally don't even see that through our telescopes, although people with really good telescopes can sort of find it.
What's the magnification here at the moment in this image you're looking
at? That's a really good question. I think we're looking at, I'm just going to we're looking at something like 40 times, 40 to 80 times maybe. I couldn't tell you off the exact magnification off the top of my head. So, can you look? Walk up
look through.
Yeah, eyepiece in.
Oh, so you can.
Yes, that's right.
If you
yeah.
want to have a
Yeah,
really good
look at that. Yes, I can take the camera out and
you do that.
yeah. So and I can sort of So with a good eyepiece, I could actually split that into 2 stars and see it. Definitely see 2 little points of light gathered next to each other. Yeah. So what we might do now is might move to a nebula. So we've seen an open star cluster, a globular cluster. We've seen a bright star, which is our next door neighbour in galactic terms. But what I'm going to do is I'm going to try and find not a globular cluster, a nebula which is quite in this part of the sky near the Southern Cross, and it's called Eta Carina. So if you just bear with us, we'll just have a look, and I'll leave the slewing on the screen just to give you an idea about the movement of the telescope. So just we're seeing some stars here and a bit of cloud. So again, just to convince you that what you're seeing is live, it's real, it's happening right now. And just as luck would have it, the clouds have just come in right where I was going to look. So,
There's a lot of clouds.
So isn't that beautiful? Look at that cloud.
And they're not moving like they were earlier. Yeah, well, it's almost stopped.
Yeah, oh look, it's pretty thick. So what we'll do is I'll flick back to the moon, and it's a bit cloudy too. So it's pretty thick at the moment. So what I might do is I've got a camera set up on a tripod, which will show you the viewing area, and it'll give you an idea about the equipment that I'm actually using here on site tonight. So here we go. Something crazy is probably about to happen again. Okay. Okay, I'll just go turn some lights on so you can actually see. Sorry? Okay, so the screen will lighten up in a moment. Okay, so on the screen here, now, I'll just wait until you can see me. On the right-hand side of the screen is what you see right now, is a couple of telescopes on it. This is the telescope that's taking the moon footage at the moment. So, pointing at the moon, this is a mechanical lens, and as the Earth turns, it in theory adjusts the telescope to match pick up the solar constant. It's not perfectly accurate as the moon drifts a little bit on the field of view, but it's not completely unuseful as we sort of move to get some good cosmos around. I can use this particular telescope to do still astrophotography, and taking anywhere from like 2 minutes to 10-minute exposures of brighter to fainter objects. So over on the left-hand side of your screen is the other telescope, which is, and this has actually been the telescope that's been showing you the images of the globular cluster, Omega Centauri, and the jewel box, and the Alpha Centauri that we saw earlier, sort of, more recently. So again, I've got different types of cameras on there. On the other mount, I've got like a DSLR Canon camera, which is taking that in live view. But on this particular telescope, I've got two purpose-built astronomy video cameras. They're a brand called G-Star, and I've got on this other telescope, which I haven't used yet, or which I might have used earlier, to look at some of the moon close up, is an imaging source CCD camera through a higher powered 5-inch, 6-inch, what we call a Matsukov telescope, which basically gives us a smaller field of view, but gives us much higher resolution, higher power than we would through this other telescope. So we've still got plenty of cloud here. Now, in the centre of the field here, we've got, you can see the operations centre here. I've got two laptop computers. Each computer's controlling the telescope, has the software to control the telescope and the cameras that are on the telescope. It's by every time I've moved the telescope tonight, I've gone to the screen on the laptop, got up a specific program, which is called Carte du Ciel, or Sky Chart in English, and I use that to tell the telescope where to point at, and usually it's within a reasonable sort of area of just a little bit of adjustment, and I centre the object in their field of view, which of course is impossible if there's lots of cloud about, which is still at the moment. Yeah. Okay, so what we'll do, that's sort of showing you the thing. I'll just, if the people here come into view too, we'll introduce you to those, the people who come along to join the party on the ground. Okay. Okay, Okay, and we've got Janice here. I said earlier, we've got Bill, who's from Delaware, and Jim. And yeah, so we're all out here enjoying the stars tonight, and the clouds sort of enjoy those as well. So yeah. Okay, so I'll put the notes to moon footage back up, so you don't have to stare at our ugly mugs all night. And just bear with me again. We'll move it to a different part of the moon, just for a bit of variety. So here are some of the large lunar mare. So this very distinctly circular mare, just near the other limb of the moon, is the Sea of Crises, or Mare Crisium in the Latin. And going across here, we have the Sea of Tranquility and the Sea of Serenity, and is in this general area that Apollo 11 landed back in 1969. Yeah. So yes. I'll see if I can actually put the cursor right at the right spot. I'll just make sure that people are seeing this. So. Yeah, this one. Okay, now. So this is where my brain is going to mush. So usually I can sort of say, look at these things straight away and tell you what they are. Okay. Right, yeah, so the Sea of this Tranquility is this area down here with, there's a sort of a bright pockmarked crater just below the Sea of Crises there. If you keep moving down to the more centre of the screen, this is the Sea of Tranquility. Landing site, Apollo 11. Let's see. Let's see, I've got to look it up. Apollo 11, here we go. Yeah. We're looking for where they landed. Yeah. Right, so just below the Sea of Tranquility is Mare Nectaris, and Apollo 11 landed somewhere in the vicinity, just near this, as we see it, just near this little crater here, somewhere around that area there. Okay, up above the Sea of Tranquility, we've got the Sea of Serenity. Okay. And this, just lost it again. There we go. And So it's Cloud City here again, folk. Oh no, here we go. Sorry, there's a bit of delay with the commentary here too, so I hope I'm not confusing too many people. So just it's very teasing us very definitely tonight. But for a cloudy night, we've done particularly well. Just to see what we have. So we're certainly not going to go to bed and cry our eyes out tonight.
So we've introduced you, then you can make your own concept.
Yeah, you're not all around them.
Oh yeah.
You can take your when you're not and we can, if you're still interested in
Oh yeah, no, you make it what we looking sort of this year.
yeah, no, this year.
Yeah.
Because when you're on the president, when you want to get a year, you don't give it to them.
That film you brought over to Edinburgh, with maybe was things like that, you have it?
Yes.
Maybe that was really good.
Yeah, no, we could. Yeah, I can sort of do some physics. And then we can back it up. We can back it up with a observation. Yeah, enough we can go out with a telescope.
Yeah, I think we're trying to go there with something.
I hear a lot of comments from people that go around about the stars and the bright Oh, that's right. So I'm sorry here again, guys. We've got some clouds. So we're just sort of working with what the sky will give us at the moment. Now, just moving to another part of the moon. Down below here, we can see Mar Nubium, this huge volcanic basin here. This circular little bite to the side is called Sinus Iridium, or the Bay of Rainbows, obviously for its crescent shape. And it's just near the limb at the moment, and you can see those craters there in fairly sharp relief. Here we have the crater Tycho, and over here too, down the bottom to the right of the screen, there's a very sort of youngish looking crater. What we might do is zoom up on that. Oh, here comes the cloud again, sorry. Now the crater I've got here, you can see in the middle there's a little dimple. And what's happened there is when the object that's created that crater has hit the moon, it's actually rebounded. The ground has been compressed by the impact, and it's that central part that just rebounds a little bit and just whirls up and creates this little nipple. So there's a bit more cloud that's just come in. So if we just things are going to sort of fade in and fade out here again, of course. So just while we're waiting for the cloud and the moon, I'm just going to show you on the screen here this shot I've just taken with the Canon camera on the tripod. Just wait for it to come up on your screen. Now you can see it. Okay, yeah. So it's like a 15 seconds of exposure with a about 800 ISO sensitivity of the chip on the camera. And that just shows you just how cloudy it is. It looks very bright because there's a lot of light that gets reflected off the clouds, and over the longer exposure, it actually turns up bright on the camera. You might notice in the gaps of the cloud there are little dots of light. They're stars. So if you just joined here now, I'm just showing a 15 second shot of the sky, just to give you an idea about what I'm dealing with here. But we've seen a few things tonight. So if you want to go to my YouTube channel, Michael Booth, perhaps put in astronomy as well, you'll be able to click on all the footage I've got tonight and have a look at it again, if that's what excites you. The other camera that's live is looking at the moon, but there's plenty of cloud there too. Just going to flick to one of the other cameras. You'll see a few stars there, lots of cloud though. And that's pretty much, I think, what we're going to see for the rest of the night, unfortunately. So I think we're going to have to sort of call it quits for tonight. I hope people have enjoyed the haphazardness of this presentation, or at least persevered with it. But that's this is live astronomy on the ground for you with the clouds. So I'll bid you all good night, and I hope that next time it's dark outside, have a look up. See if you can find the Southern Cross. Saturn and Mars high in the sky during the evening at the moment too. So Mars is quite recognisable as a little red blob near the constellation of Scorpius. And Saturn is not too far away from there too, so you can. So if you find a star chart or that's relevant for now, it'll probably give you an idea about where to look for Saturn and Mars. Okay, so thank you very much, and good night.